All right, so this is the second half for the video solutions for the Planck's Law homework that is due tomorrow morning. So let's start with number 7. It's going to be very similar to what we saw in number 6, only now instead of giving us a certain energy and trying to determine the number of photons that are required to provide that energy when we have either frequency or wavelength data, now we want to calculate the total energy. So we're going to calculate the energy per photon and simply multiply that by the number of photons. So we are given the wavelength. So for the energy per photon, we'll just use hc over lambda. And then we're going to multiply that by the number of photons, which is 1.5 times 10 to the 13 photons. So we have 6.63 times 10 to the minus 34. And I'm going to go ahead and put this on successive line. So 6.63 times 10 to the minus 34 joules times seconds times 3 times 10 to the 8 meters per second divided by 3 times 10 to the minus 12 meters. Now this is going to be per photon, and then I'm going to multiply that by 1.5 times 10 to the 13 photons. So now we got some units that will cancel. Seconds cancel, meters cancel, photons cancel. And now all I need to do is to simplify this expression. So we have 6.63 times 10 to the minus 34 times 3 times 10 to the 8 divided by 3 times 10 to the minus 12, and then we're going to multiply that by 1.5 times 10 to the 13, and that gives me a total energy of 0.9945 joules. Which is our answer for question number 7. Okay, let's move on to question 8, and this is very much like questions 3 and 4 that we did on the previous video. I'm going to calculate the frequency first with the relationship C equals lambda F. So frequency is C divided by wavelength, which is 3.0 times 10 to the 8 meters per second. Now, again, I'm given the wavelength in centimeters, so I need to convert that to meters, which will be 6.8 times 10 to the minus 7 meters. If you cannot do that in your head, you really need to work on your unit conversions, because there are 100 centimeters in 1 meter. So just as a quick example, 6.8 times 10 to the minus 5 centimeters. There are 100 centimeters in 1 meter. When I divide, I'm going to subtract exponents. So minus 5 minus 2 is minus 7. That being said, you really should be at the point where you can do that one in your head. And now I want to simplify this expression to find my frequency. So again, we have 3 times 10 to the 8 divided by 6.8 times 10 to the minus 7. And I get a frequency of 4.41 times 10 to the 14 hertz. I could also use an inverse second. So that answers the first part of the question. Now for the second part of the question, we want to find the energy. Again, my advice would be to use the frequency because I think ultimately you'll do less work. So E equals HF, 6.63 times 10 to the minus 34 joules times seconds, times the value we just found, 4.41, times 10 to the 14 inverse seconds. And of course, the seconds will cancel. And now I just have a simplification step. 6.63 times 10 to the minus 34 times, make sure you use your parentheses if you have a TI calculator, 4.41 times 10 to the 14. And we get an answer of 2.9. Getting ahead of myself. 2.92 times 10 to the minus 19 joules per photon, which is what they're asking for in this question. Joules per photon. Okay, question number 9. Wavelength of green light from a traffic signal is centered at 5.20 times 10 to the minus 5 centimeters. So that is a wavelength and I guess since it's a green light, let's do it in green, of 5.20 times 10 to the minus 7 meters, which is also the same as 520 nanometers. We want to find the frequency, so remember C equals lambda F, which means F equals C divided by lambda. 3 times 10 to the 8 meters per second divided by 5.2 times 10 to the minus 7 meters. And again, the meters will cancel. My answer will be in an inverse second or a hertz. So now it's nothing but a plug and chug problem. So 3 times 10 to the 8 divided by 5.2 times 10 to the minus 7. Get an answer of 5.77 times 10 to the 14 hertz, or inverse seconds. So number 9 is a pretty straightforward problem. Finally, let's look at number 10. So we have an added caveat to this one on identifying the type of electromagnetic radiation. So we'll deal with that shortly. We want to find frequency of light given a wavelength. So again, we're going to use C equals lambda F. F equals C divided by lambda, which is 3 times 10 to the 8 meters per second. Divided by 4.25 times 10 to the minus 9 meters. Which, by the way, that's 4.25 nanometers. That's not in the visible spectrum. In fact, it may be even shorter than ultraviolet light. So we would probably just need to look that up in a reference. So we're going to say UV or shorter. Just Google that. In terms of the frequency, 3 times 10 to the 8 divided by 4.25 times 10 to the minus 9, get a frequency of 7.06 times 10 to the 16 hertz. Remember, you could also use an inverse second for that one. So this completes the solutions for this worksheet. I would definitely be prepared to do one of these in class tomorrow, one of these in class on Friday for a quiz, and the next time we do have a unit test, certainly I would expect you to be able to handle any of these that we've talked about the last couple of days.